All right, so this video is going to walk you through part 3 of the UT lab. By now you should have answered questions 1 through 4, and you're going to use the gauge height that you just figured out, as well as those new elevations based on the gauge height, specifically at the 100-year flood, to map a flood hazard map of Grand Prairie. Now for this particular part, you're going to be looking at 2 topographic maps side by side. You're going to be looking at the Irving and Ulysses quadrangles. They are different parts of Texas. And based on the number you got at the 100-year flood mark, added with the gauge mark to give you an elevation, what you're going to do is you're going to determine what the flood zone is. So let me give you a hint. This number right here is the number you got right here. If you did it correctly, you should have a number between 400 and 500. I'm not going to tell you the exact number, between 400 and 500. Now based on that, I'm going to go look at the 2 different topographic maps to see what the flood zone would be based on that number between 450 and 500. All right, so if I go to Schoology or Canvas, it really doesn't matter. There are 2 PDFs here. One is for Irving and one is for Ulysses. I went ahead and put them side by side for you for the sake of discussion. All right, so I have the Ulysses one right here. You can see that's the one that's open right here. And then in a separate window, I went ahead and put the Irving one. Now, basically in Texas, here's how it works. Irving is to the left. Ulysses is to the left of Irving. So if you can imagine, I'm going to do my best to pretend like you can kind of put these together. This highway right here continues over here. So it's as if the maps were joined together, kind of taped together. You kind of continue your story over here. All right? What I'm going to do is I'm going to attempt to show you what's going to happen. So again, if I kind of move it out, you can see how that would work a little bit better in terms of understanding. Let me scroll over here so you can actually see where the actual river is. So you can kind of see right there where, if I could move it down a little bit, the river flows over here. The highway flows this way, so on and so forth. Now based on that number you just got that I told you is between 450 and 500, I have to figure out the flood zone around this Trinity River. I'm going to blow it up because I'm old and my eyeballs will not work like that. So I'm going to take it and I'm going to expand the map out to see if I can figure out the contour lines to look at the actual hazard map. All right, so let's take a look. First of all, at the very, very bottom, it told me that my contour interval is going by 10 feet, which means every brown line on the topographic map is going to be 10 feet. All right, so let's see what that means. If I come over here, I can see this is 450, kind of walk it around, 450, up here is 500. So again, they're going by tens, right? So 450, 460, so on and so forth, which means I'm going downhill to go to the river, I go back uphill to go to the highway. That just makes sense. All right, the number I just told you, hint, 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 that you should have as your elevation is between 450 and 500, which means if I was to kind of color code this in, anybody living from the river, which is basically the floodplain because those are lower than 450, so basically from here to about here, based on the number you got, would all be within a flood zone. So you can imagine you'd be coloring all of this in to make your actual flood zone. Which means, yes, look at this. This is 450, this is 450. If there is a flood, I hope this highway is raised because it's going to be flooded underneath. Okay, it's going to be completely flooded. So again, hopefully all these parkways, all these roads are up like the spaghetti bowl, because otherwise they will be completely covered in water. So if I go back and I look at my UT lab, it says by looking at that, you now understand what the flood hazard map is. You do not have to make the map. You're just going to use that understanding in just a minute to answer some questions. For the remainder of part 3, though, it does ask you, based on what you know, is the Trinity River flooding in Grand Prairie today? What is the mean discharge of the river on today's date? So the first thing you have to do is write down today's date, because UT is going to ask you that. So let's go take a look. If I click on the website, I am looking at it on Wednesday, the 17th, okay, of October. It takes me directly to the real-time data for Grand Prairie. If I scroll down again, my goal is to see, is it flooding? I don't care how cold or hot it is. I don't care about the temperature of Grand Prairie. Rain obviously is going to come important. I can see today, October 17th, that it's been raining. There is some precipitation, but that doesn't mean it's flooding. So let's continue down. My goal is to see, is it flooding? All right, well, take a look here. I have discharge. On today's date, today's discharge is a little over 10,000 cubic feet per second. And if you remember, you had to answer on question number 3. So let's go up here. About the discharge. It asked you, sorry, let me find question 3 here for you. Okay, right here. What is the discharge of the 10-year flood and the 100-year flood? They want to know about the 100. So question, go back and look at your worksheet. What was the discharge? You should have gotten about 65,000 feet cubed per second. So if I go back and look at the website today, is it near 65,000? No. So as of right now, I'm thinking the answer is going to be no. Okay, daily discharge, again, this is the most recent. That's nowhere near 65,000. All right, well, let's look at gauge height. On gauge height, you had to answer what is the gauge height for the 100-year flood. Again, that particular question was on number 4. So if I go back and look at question number 4 here, what was the gauge height for the 100-year flood? Okay, so you need to look at that and then go back to the actual website. Does the gauge height go near that number, yes or no? Because remember, gauge is the thing in the water that's going to measure the water. This is what's going to tell you if it's flooding. So I'm going to record the answer down here as to whether or not it's flooding. It says, what is the mean discharge of today's date? Again, I just showed you that. The mean discharge was the one that was kind of highlighted for you. That particular one would be right here, the mean discharge. Okay, don't get it confused. It's not this one. It's the mean, the average. All of that concludes kind of part number 3 on your lab worksheet.